Welcome to a video on solving absolute value inequalities. Before we begin, let's make a note. When solving an absolute value inequality that involves a greater than or equal to or a greater than symbol, think of this as an or statement. And if the inequality is less than or equal to or simply less than, then that is an and statement. So we need to distinguish the difference between the two from the start before setting it up. On letter A of this problem, solve each inequality and write your answer in interval notation. Notice here we have a greater than symbol. The absolute value expression 2x minus 5 is greater than the value 3. So another way to look at it is to interpret this on a number line. To be greater than 3, think of it as being more than 3 units outside of the circle. Now, if you have a circle here, think of this as the radius, 3 units, and you want to be more than 3 units from the origin. So outside of the circle. Any number that's outside of the circle is going to be more than 3 units from 0. So we would shade everything to the left of -3 and to the right of +3. So this gives us a graph that has a gap, which is disjointed, and therefore think of it as an or statement. In other words, 2x minus 5 now is less than -3. This statement will describe all the values to the left-hand side of -3 on the number line. Or 2x minus 5 is greater than 3. So this statement here will describe all the points to the right of the +3. Now we have two inequality statement that can easily be solved. And so add 5 to both sides, which makes it 2x less than 2 now, and then divide by 2. So here we have x less than 1. Less than 1 means from -infinity to 1, exclusive of 1 due to the strict inequality. The or means the union symbol. And then on the second inequality statement, we're going to add 5 to both sides, making the right-hand side an 8, and then divide by 2. So x is greater than 4. Greater than 4 means from 4 all the way to the right of it, so 4 to infinity. And hence, in interval notation, this is the solution set. Now for part B, we have an absolute value expression that's less than or equal to 0.2. So the less than means that it's going to be an and statement. Again, we can interpret this using the number line. Make sure that the absolute value term is already isolated from the start. If not, then solve for the absolute value term first. So again, we want it to be less than 0.2 units from 0. So think of it as within the 0.2 mile radius or the 0.2 unit radius. So that would include all the points within the circle. And hence, on the number line, we would label this as -0.2 and this point here as +0.2. And hence, to describe all these values that are inside this circle, we do not have two disjoint sets like part A, and therefore it's an and statement. The expression inside the absolute value, 3x minus 3 fifths, is in between the -0.2 and the +0.2. So we have an and statement, which means it's a double inequality. Either 3x minus 3 fifths is greater than -0.2 and less than +0.2. So I'm going to join those two inequalities together with the and using a double inequality statement and then solve for x from there. Now, to be consistent with the values that are provided here, let's go ahead and change the 0.2 and the -0.2 as a fraction, which is 2/10 and -2/10. So that reduces to positive and -1/5. That way we're consistent with having all fractions across. So at this point, let's go ahead and multiply everything by 5 to get rid of the fractions. Distribute that to every term And now we get -1 is less than 15x minus 3 less than 1. So again, -1/5 times 5. The 5 divides out, giving us a -1. Distribute the 5 into the linear term, which gives us this. And then same with the furthest right side of the statement. And now let's get rid of the 3 here by adding it to the right and the left of the inequality signs. So we get 2 is less than 15x less than 4, and then divide everything by 15. So x is in between 2/15 and 4/15. So in interval notation, that's 2/15, comma, 4/15, parentheses around those values, which means that all the numbers in between them, excluding the endpoints. Now let's take a look at letter C and part D. So on letter C, the absolute value term is already isolated. To interpret this, it means 3x minus 1 is greater than or equal to -4 units from 0. So to be more than a negative unit from 0, that's everything that's on the number line. So every point that you compare it to from 0 is going to give you a non-negative distance. So a non-negative value is always going to be greater than or equal to a negative number, always making that statement true. So therefore, every value is a solution to that statement. For letter D, we need to isolate the absolute value of a plus 2 first. So we're going to start with subtracting 30 to both sides, resulting in -4 times the absolute value of a plus 2 is greater than -18. Now we're going to divide everything by -4. Again, watch out for the common mistake of distributing the -4 inside the absolute value symbol. That's incorrect. Dividing everything by -4, we are left with the absolute value of a plus 2 is less than, careful with this as well, we need to change the inequality symbol since we are dividing this inequality by a negative number. So remember, division or multiplication by a negative number switches the sign on the inequality symbol. So resulting in 9/2 on the right-hand side. And now let's sketch the number line. A plus 2 is less than, strictly less than 9/2 unit from 0. So this is 0, this is 9/2. We have a -9/2 here. So we want it to be within the 9/2 units. So everything inside the circle. So a plus 2 is in between -9/2 and +9/2. And now we can solve for a by subtracting 2 to both sides. Subtracting a 2 is equivalent to subtracting 4/2. So -4/2 and -9/2 is -13/2. 9/2 minus 4/2 is 5/2. So in interval notation, this is our solution set. We have one more problem on solving an absolute value inequality. For this problem, write the expression as a single inequality involving absolute value. So notice that from the statement, x minus 5 is in between -3 and +3. So the expression x minus 5 is basically less than 3 units from 0. Now this time we want to include the endpoints because of the equality symbols with those inequality signs. So less than 3 units in absolute value means the expression x minus 5 is less than or equal to 3 units from 0. And there it is.